Hey, algebra kids. I'm home today with my kids, so I'm gonna teach you 7-3 over video. 7-3 is the graphing section, which is kind of whatever. I'm not terribly thrilled with graphing, but that's just one thing that we have to get through. So, and reciprocal functions. We've been dealing with these guys, for the last two sections. Has to do with stuff when you have like x's in the numerator and x's in the denominator. So like, I don't know, x plus 3 over x squared minus 9, and simplifying those and trying to figure out how to break those things down. So really reciprocal functions have stuff in the top and stuff in the bottom. Really, they're kind of a fraction. And now we're just worrying about graphing them and what the graph looks like. So the parent function is 1 over x. And you guys might remember from when we studied parent functions that the parent function looks like this graph, which I kind of call boomerangs because they kind of look like little boomerangs in the corner. So in the top left corner, or top right corner, bottom left corner, and they go on forever like that, up, down, left, right. And they have these two dotted lines that they will never touch, and those two guys are called asymptotes, and I think we've talked about those words before. So it has both a vertical asymptote and a horizontal asymptote. So this one is vertical, this one goes up and down. So this one is a vertical, asymptote is how you pronounce, is how you spell that, or I usually just call it a va. Okay, and that va is at x equals 0. Okay, because it's at 0, but since it's going up and down and it's cutting through the x-axis, it cuts through the x-axis this direction, that's at x equals 0, okay? This guy here is a horizontal asymptote, or a ha, and this one right here is cutting through 0, but it's cutting the y-axis. So his ha is at y equals 0, okay? So just the function 1 over x, remember that. He has a va at x equals 0, a ha at y equals 0, okay? Now, they're going to start to add in different numbers into here. So like this guy, they want us to look at this thing and then, kind of determine where the va is. And it says specifically what we're looking for is determine the value of x for which it is not defined, okay? We've had problems like this before where it says like 1 over x minus 3, where is x undefined? And we basically say, what can x not be in order for the bottom not to be 0. I don't want 0 to be what the bottom is, okay? And those you could basically do in your head because you look at that and say, okay, if I were to plug positive 3 in there, then I would end up with 3 minus 3, and that would end up being 0, and I don't want that to happen. So in that case, we say x cannot be equal to 3. Okay, this is where the x is undefined or not defined, okay? But when we look at something that looks like this, where it's a little bit more complicated in the bottom, 2x plus 5, doing that in your head is a little bit harder. So what I usually say is, we don't really care about the 3. The 3 we can just ignore for right now, okay? But the 2x plus 5, we literally say 2x plus 5 cannot be 0, because we don't want that bottom to be 0. And then all we do is just solve the equation as if this guy were an equal sign, okay? So I'm going to subtract the 5 over, and then 2x cannot be equal to negative 5, and then divide by 2. So x cannot be equal to negative 5 over 2, or if you don't like writing it as fractions, negative 5 over 2 is negative 2.5, or negative 2.5. Okay, so that's where we say x is not defined. X cannot be equal to negative 2.5, okay? Now, the special thing about that is this guy, since x can't live there, that's where your vertical asymptote is going to live, okay? So if we were to graph this thing, instead of my vertical asymptote being here at 0, it would be at negative 2.5, which is right here. So it would look like this instead. My horizontal one's still going to be here, but my boomerangs would be in this corner and this corner instead, and that vertical asymptote would be at negative 2.5 instead of here at 0. Okay, so that, where x is not defined, this determines where your vertical asymptote is. Okay, so let's go down here to this guy. They're going to ask us identify the asymptotes, domain, and range of each function. So let's do the va, let's do the ha, let's do the domain, and let's do the range, okay? And you'll notice some trends here that go with this, okay? So we're looking at this function right here, and we're saying 2 over x minus 3, okay? And I just told you kind of a little cheater of how to figure out where the va is. If you say x minus 3 is not equal to 0, and add the 3 over, x is equal to, or not equal to 3. So that's where my vertical asymptote is, except we say x is equal to 3. That is the vertical asymptote, okay? So rather than not equal to 3, we say equal to 3 because the x equals 3 is the line, that guy right there, okay? And I don't know if you can see these very well. I'm going to make these a little bit darker, but here is your y-axis and here's your x-axis. So my vertical asymptote, you can see here, is at 3. I have a helper. Yeah, I don't like it either, do ya? So x equals 3, that's my vertical asymptote, okay? The horizontal asymptote is still going to stay at 0, and you can kind of see that on the graph that he stays right here because your little boomerangy things are there and boomerangy things are there. We'll talk more about horizontal asymptotes later, but that's y equals 0 is going to be your horizontal asymptote, okay? Now, here's the extra special thing about domain and range, okay? Your domain goes strictly with your va, okay? So remember that domains have to do with the x's. So when we look at the x's, we say, does this graph go to the left forever? Yes, he goes to the left forever. Does he go to the right forever? Well, this little bar would make him go to the right forever, except he doesn't cross along this line. So he goes to the left forever, he goes to the right forever, but he doesn't touch the value of 3, okay? So if you look at the va, those kind of go together, okay? Looking at the range now, the range is talking about the y coordinates, okay? So the y's, we're talking about up and down, so this function will go up forever because of this top little boomerang. He'll go down forever because of this bottom little boomerang, but it won't cross this place here in the middle, and that is at 0. So we say the range is that y is not equal to 0. Aha, look at that. That's where the ha lives, okay? So the horizontal asymptote is the guy that he doesn't touch. That means that your range says that y doesn't equal 0. You know, so those va and domain go together, ha and range go together, okay? That's kind of how that works. Let's see if we can figure it out from this function here. I'm going to draw my y-axis here and my x-axis here, and we're going to see what this thing looks like, okay? Now in this case, we see that the vertical asymptote is this line, okay, and that is at a value of -2. If you look at our equation, x plus 2, this is my function that I have, and if I set him not equal to 0, x will be -2. So that's where my va is located. But my ha is not at 0. He's shifted down a little bit, okay? He's shifted down at -1. Well, if you look in the graph, what in the graph tells me that he's going to, or excuse me, in the function tells me that he's going to be at -1. This number right here, this number says that he's shifted down 1 and he's down at -1, okay? This one, this graph over here, did not have anything added or subtracted onto the end of here, so the ha stayed at 0. Versus this one says he's moved down 1, and that's why your horizontal asymptote is down, okay? So let's do the va, let's do the ha, let's do the domain, and let's do the range, okay? So for the vertical one, we said was at -2, but is that x equals -2 or y equals -2? We have to look at which axis it's cutting. So -2 is cutting this x-axis right here. So it's x equals -2, which means my domain is x can't be -2 because that vertical asymptote is a line that he doesn't touch. So if x is not touching that, then it's not going to be at -2, okay? The range is the horizontal asymptote, which is this guy here. He's cutting at -1, but he's cutting the y-axis. So y is equal to -1. That means y is not equal to -1 for the range, okay? So again, the vertical asymptote and domain, horizontal asymptote and range, those kind of go together, okay? And you can see that from the graph up here, or from the equation up here, that these two numbers tell you exactly where that va and that ha are, okay? So if you want to label those, this will make it easier for you in the long run. This is where your ha is. This is where your va is. The only difference is you use the opposite sign for the va, because when you set that equal to 0, that's going to switch and be a -2 instead of a +2. Okay, so that's kind of how that will all work. Okay, Now we go down here and it starts talking about the horizontal translation and the vertical translation, okay? And that goes up to what I just got done talking to you about. I'm going to give you another example. Let's do x minus 3 plus 5. Let's do that. Okay, so this guy here, this minus 3, this kind of goes back to, you know, when we had that transformation grid, that big grid that has all of those lines on it and stuff. This guy is kind of like in parentheses on the bottom there, and we have to figure out how he's shifted. So up, down, left, right. The minus 3 is going to shift him to the right 3, okay, because we use the opposite sign, okay? And or you can just think about it as x minus 3 can't be 0, so that means x equals or can't be 3. That means your vertical asymptote is at 3. Okay, so however you want to think about it, it all goes together. It's either a transformation to the right 3, it means x can't be 3, it means that's where your vertical asymptote is. It all means the same thing. Those are just different ways of saying that's a horizontal translation to the right 3 units. Okay, we always use the opposite sign. Minus usually means left, but minus actually means to the right. Okay, and then we have to decide what this plus 5 is doing. Okay, this guy just makes him go up or down. Okay, so kind of like our horizontal asymptote, this guy is going to make him go up 5 units, which moves our horizontal asymptote to y equals 5. Okay, we'll do some more examples down here, or on the next page, I guess. On the next page, and you'll see, you know, again, how that works, okay? The last thing that we need to talk about, I'm not going to talk about part B, but part A, if you ever have a number on the top of here and it's not 1, what's going to happen to it is this. Let's use that same example that I had, but instead of 1 on the top, let's put a 4 on the top. Okay, so what's going to happen is on my graph, this 3 is shifted 3 units to the right. So 1, 2, 3 units to the right. Okay, 5 units up. 1, 2, 3, 4, 5. And what I do is I usually just put a dot there. Okay, 3 to the right, 5 units up. And what's going to happen is my asymptotes are going to cross at that place. Okay, that's just the dot where my asymptotes are going to cross each other. And then I'm going to have a boomerangy things that look like this. Don't write those in yet, because this 4, all that 4 is going to do is going to stretch him out. So instead of him being kind of like an L, he's going to be more of a C. Okay, so I'll show you kind of what that looks like. Instead of him doing that, he's going to look more stretchy, I guess. Okay, little boy. I apologize if you're trying to concentrate and listen to him at the same time. He's going to be stretched out, so it's not going to be much of an L. It's going to be more of a C. Okay, so more like that and more like that. Okay, and that's all that 4 does. Really doesn't change like where the horizontal asymptotes, where the vertical asymptotes are at, just how stretchy he is. Okay, more of a C, less of an L. Okay, and I'm not too particular about where you plot your points at, just as long as your vertical asymptote and your horizontal asymptote are in the right spot. That's really what I care about. Okay. All right, let's go down to example 3. We just got a couple more of these. I'm going to get rid of this 1/2, so cross him off, because we're not going to deal with that B value for now. What we're going to do is we're going to figure out, we got to state the domain and range. We're going to graph this guy and then do the domain and range. So this minus 2 is going to move him to the right 2. This positive 2 is going to move him up 2. Or if it helps you to think about it, x minus 2 can't be 0. So if we add the 2 over, that means x can't be 2. So we've got a bad place at 2 right here. And up 2, okay? So right 2, up 2, if I go to the right 2 and up 2, this is where my dot is at, and that's where my asymptotes are going to cross each other. So there and there, okay? And he's just going to look like boomerangy things here and boomerangy things there. Okay, so then we just have to do domain and range. So the domain is the x's going left and right. He'll go to the right forever. He'll go to the left forever, but he's not going to touch this line here in the middle. So x is not equal to 2. That's kind of like what we found there for the vertical asymptote. And then the range is determined by this plus 2 number. So up, he'll go up forever. He'll go down forever, but he won't touch this line here in the middle. which is y is not equal to 2, okay? So that's how that domain and range comes into play, okay? This one over here, we do have a number on the top here, -3. We'll talk about that here in just a second. Put a little star by the negative because that is going to do something else as well. Hey, little boy, shh. All right, this +1 moves him to the left 1 unit, and -4 moves him down 4, okay? Or x + 1 can't be equal to 0, x can't be equal to -1 if we move the 1 over, okay? So left 1 down 4, I'm going to go left 1 down 1, 2, 3, 4, there's my dot, okay? Put my asymptotes in there, this one, and then my boomerang guys are going to go like this, but don't draw those in yet, boomerang guys goes like that, except in this problem, there's a minus, which means this is the only time it ever flips. It's going to actually go in this quadrant and this quadrant, so kind of like in the second and fourth quadrant instead of the first and third, okay? If you're looking at these being the quadrants, right? So we are going to put them like that, and because there's a 3 there, he's going to be a little bit more stretched out, so more of a C, less of an L, and that's what he will look like, and I don't know, something, I'm trying hard, something like that, okay? Something of that nature, that's what he's going to look like, okay? Domain and range, domain, range. Domain is the x's, so going to the right forever he will, going to the left forever he will, but he won't cross this place right here, which is at x equals -1, so x won't be equal to -1 like we solved for in the equation. And then the range, he's going to touch everything going up, he's going to touch everything going down, but he won't touch this line here, which is at -4, so y can't be -4, okay? You're going to get really fast at these, like you're going to go through this homework assignment lickety-split, and it's not going to be anything hard for you to do because you can basically just look at this equation and solve for everything, the domain, range, everything, okay? All right, let's do this last problem, and then I'll let you get to it. Philip is taking a non-stop flight to Hyderabad, India for a business trip. A one-way trip is about 9,000 miles, and what he's looking at doing is write an equation to represent the travel time in terms of speed, okay? So basically, the time that it takes you to get there is going to depend on how fast you're going, right? If I have a 300-mile trip, and I'm going 60 miles an hour, I would divide that by 60, and that means it's going to take 5 hours to get there, right? 300 miles, 60 miles an hour, it's going to take 5 hours to get there, assuming I don't take any stops, but whatever, okay? So what we've done here is we've taken the distance and divided by the rate, and that's equal to the time. You guys might have done that in Mr. Moose class, maybe. Time is equal to distance divided by rate, or you might have done like distance equals rate times time. That's the same equation, but we've just divided the rate over, right? Distance divided by rate equals time, okay? So this equation is what we're going to use to set up, and we're going to say time is equal to distance divided by rate, except we already know the distance is 9,000 miles, okay? So we can put that in there, and they actually have that written over here in the graph. Aha! So there's that. And we see from this equation right here that r can't be equal to 0, right? We set the bottom not equal to 0. And that gives us where this vertical asymptote is located, okay? That means our rate can't be 0, which makes sense, I guess, right? Like you're not going to go anywhere if you go 0 miles per hour. So your mileage is not going to start until after you increase your speed a little bit, okay? And then part B says, explain any other limitations to the range or the domain in this situation. Most of the time, we just have a horizontal asymptote and a vertical asymptote to deal with. But since this is a story problem, let's talk about range and let's talk about domain. Okay, the domain is the x's, and our x's in this case we labeled as the rate, okay? And, or the speed, I guess. Let's go speed. I know I'm almost done. I'm almost done. Yes. So domain is speed, and then the range is going to be the time. So we have to talk about those. We know that we have a vertical asymptote and a horizontal asymptote here at 0, but in addition to that, really, it doesn't make any sense to do any of this or any of this because time can't be negative and speed can't be negative. Not even if you're going backwards, speed cannot be negative. So in addition to the x can't be 0, y can't be 0 type of thing, we say that time has to be greater than 0 and the rate has to be greater than 0 because it can't be negative. So when you have a story problem, it's not just restricted to the domain or to the asymptotes. It has an extra little piece to it, and most of the time being that it can't be negative. Okay, so hopefully that kind of made sense. You know, these problems should go by very quick because you can basically pick apart the equation and find the domain range that way. Okay, your homework assignment looks like this. Do all of them front and back. You should get through them real quick, and I'll hopefully see you again tomorrow.